perfect. That's working.
Okay, so it seems everything is working.
Are we
That's
using
amazing.
these? Do we need to?
Yeah.
Maybe
Or
one
they're just
minute
always on?
for the light cam. It's on.
Usually fill in. We had one.
It's okay.
It's
Yeah.
just-
I think we've got it
Oh,
under
here
control.
comes.
Thank you so
The
much.
numbers double
Thanks.
at first.
Yeah.
So we're at 10:30 now. So thank you everyone who's managed to come along to this final OSR panel discussion. And so this is one that was generated by the community. So there's clearly a lot of interest. And so the focus on this is going to be large open data repositories, how we can ensure that they're sustainable and what implications there might be for global reuse. We have a great panel of speakers who will talk through some of these issues. We have a very proud sponsor in MathWorks, and so we have Vijay Iyer, who is going to talk a little bit about MathWorks and how they're contributing to sustainability in these issues. So Vijay, thank you very much for joining us.
Thank you for the introduction. Uh-oh, I have an echo.
We can't see him.
Do you hear the echo?
No.
No, you're coming through
sound great.
fine.
Okay, great. I'll tune it out. So, thank you for the introduction. I'm Vijay, the neuroscience specialist at MathWorks, and I'm really excited to listen in on this panel. I just wanted to share maybe a couple of things about what we've been doing and seeing in relation to open data. I'm really excited about this topic. So, these are the three key examples of open data repositories. The Dandy Data Archive for cellular and systems neuroscience, Open Neuro for human brain mapping data, the Allen Brain Observatory as reference data sets, large-scale data sets for cellular neuro. And we've been working with each of these to some degree, and I wanted to share a couple of the key learnings we've picked up to date. So one is open code really can enable open data. So we've been involved with projects like MAT-NWD that works with the Neuro Data Without Borders standard. And we've started to work with the BIDS data standard in a project called BIDS Toolbox, which I'll mention more later. Another is that when you have cloud compute and cloud data, this can really lower the barrier to entry and globalize access. One thing that's been a key foundation for our projects has been that we have a lot of ways to work with remote data, and I'm counting now 94 different MATLAB functions that are ready out of the box to work with remote data, things like S3 buckets, but other kinds of cloud data. Now, I think we're seeing that you need to plan for users to progress through a series of compute environments. You know, as you want to start with a low barrier to entry, and then you want to start giving people more power over time to do more complete projects. So, for instance, you might start with MATLAB Online to do lightweight examples. You might then progress to what we might call a science gateway, a service that's geared towards a specific domain. You know, it can be for, you know, we've been working a lot with Dandy for cellular and systems neuroscience, but it could also be for open neuro or even more specific fields, you know, specific to MRI, EEG, et cetera. And this might be where you do full examples and exploratory research. And then ultimately you might need a cloud architecture or a compute that's tailored for your PhD research. And so we've been working on reference architectures to allow people to make cloud environments for their purposes. And last but not least, some of our projects, like the Allen Brain Observatory Toolbox, which I'll mention, we really think they benefit from rich, intuitive command line interfaces. So not just make it possible, but make it rich and intuitive and clear and domain specific. So on the theme of enabling global access, I want to share an important announcement that came out just last week. So this is hot off the presses. It was announced in the MATLAB blog by Mike Croucher that MATLAB Online is now available to anyone in the world with 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 an access here that provides many toolboxes to anyone in the world, so without a MATLAB license. And this can easily be connected to GitHub. Um, and we now offer this open and MATLAB Online badge, so people can, with one click, launch MATLAB Online. And again, many examples will work for anyone worldwide without a license. So one project I've been working on actively is sort of an open science reference project called the Brain Observatory Toolbox to work with that Allen Brain Observatory data resource. So to emphasize again, it's globally viewable, it's globally runnable via MATLAB Online, and this happens to work with cloud-based data, so it's global cloud-native remote data access, optimized data that is worldwide. And I've been taking some of the learnings from that to work recently on a BIDS toolbox. Been working together with a talented recent computer science grad named Alex Estrada, who's going to start the neuroscience grad school at Penn in the fall. And this will work with that S3 data. Open Neuro Data is on AWS through the Amazon Open Data Sponsorship Program, and represents the data with objects, so using object-oriented programming. Represent, for instance, the BIDS data set and its participants and attributes, and then have objects that represent different data stores that represent specific participant file sets, say, for example, for specific modalities and stages. So to recap, I just hope I've given you a flavor of some of the things we're doing and enabling in terms of open data around the world. And I'm really excited to hear the panel discussion today. Thank you so much.
Okay, so following that, what we'll do, introduce some of the speakers. So I'd like to thank them all for coming today. So we have Suzanne Witt, who's joining us from the University of Western Ontario in London. And Suzanne is a neuroimaging analyst, has been there since 2018. Previously was a senior research engineer in Linköping in Sweden. Linköping. I'm Swedish, and yet I'm getting this wrong. And also carried out a PhD at Wisconsin-Madison. We have Claude Bajada, who is a lecturer in the Department of Physiology and Biochemistry in the University of Malta. Was previously a postdoc at Jülich, and carried out his PhD at the University of Manchester and his master's in UCL in London. And also Tom Nichols, who's a professor of neuroimaging statistics at the University of Oxford, and a Wellcome Trust Fellow in Basic Biomedical Science there. Previously worked in Michigan and was Director of Modelling and Genetics at GSK in London and University of Warwick following that. So thank you very much to the panelists for joining us today. So what we're hoping to do is to discuss some of the sustainability, some of the reusability issues related with large open data sets. So to start off, one of the problems that we might have is with these very large data sets, there's a huge number of hypotheses that are being tested by many different labs over time. And how can we keep false discovery rates acceptable with this multitude of analyses that are being carried out?
Sounds like a question for me.
It might be, yes.
Well, the first thing I would distinguish between is the false discovery rate, or sort of chance of any errors. So the first thing to realize is that we have different ways of measuring false positives when we're talking about multiple testing. And it is true that the chance of any errors, that's the thing we correct with family-wise error rate or Bonferroni or something like that. That is a probability, and the more tests you look at, no matter what. So if you've got like 1 million tests and you do correct for them, and then you do another 1 million tests, well, you basically used up all of your family-wise error rate in that first test, and then the next one. So, you could say like, well, I should be controlling my lifetime family-wise error rate. But you exhausted it long ago. So, I mean, it's not really a practical thing. And so I think what we've arrived at through science is that you have to have a scope of inquiry, and then you basically follow the best practice, which is that you control false positives on that scope. And so that's what we do in any one paper, and typically any particular contrast. Although honestly, if you're doing a set of contrasts, you maybe want to correct over those as well. Okay, so those are the traditional things. But I think maybe what this is getting more at is that when you have something like the UK Biobank, you have all these different people, doing many papers who are asking similar questions. And I can't get too exercised about it because I feel like this is the work of meta-analysis. And whenever we look at the literature, we're all automatically doing a meta-analysis in our head, even if we're not doing a formal one. And you are judging those. And I think the only sort of asterisk that would hover up is to make, when you're looking at multiple results from the same data set, if they're all, asking the same question, that maybe these could be correlated, right? And so if you see 10 papers that all like ask the same question about intelligence and global, say total brain volume, and they're all finding the same answer, that's great. But it's not really like there's 10 independent papers. And then just a quick follow-up is that, so that's when we talk about the chance of any errors, that's a family-wise error rate. But there's actually something quite cool about the false discovery rate, because it's not a probability, it's the expected proportion of false positives among all the detections. And as an expectation, as an average, it doesn't change over time. So if I'm looking at 1 million tests and I'm controlling FDR in those, and I look at another one and controlling FDR in those, your average FDR is controlled. It doesn't, unlike probabilities, that just get bigger and bigger and bigger the more sort of chances you have. Controlling an expectation is just something, FDR is controlled there, FDR is controlled there, and I can just do that in perpetuity, and it's fine. The interpretation is retained within. Did you want to add something?
I have maybe a comment on this, and it's not a statistical one. It's just one that I see a lot from like physiology researchers and like wet lab researchers, where you never publish a paper based on like one experiment or one data set. So I wonder if maybe the future with these big repositories would be to save them for like exploratory research. You find something and then you'd have to have a smaller sample to confirm whatever you find.
Well, I mean, in any kind of machine learning tool, I mean, that's the new perspective. And certainly with the large data sets, you have the capability. But I guess you're saying, should there be a community agreed held out?
Yeah, and perhaps the holdout shouldn't be from these large data sets, right? You would.
Well, I mean, that's just a fact of life now. If you want a high impact publication, you basically have to show that you can replicate your result in a different data set. Yeah. But in the ABCD, I'm involved in the biostatistics working group of ABCD, and we did discuss having defining a holdout, but it just didn't seem like it was in the end practical. Or actually, I think maybe it's better if every individual does their own holdout, because then there's kind of random sampling of that.
Right, not something.
Yeah. And I think we should invite people to make comments along the way, right?
Please do ask questions on each of the questions that come up. So do you think there should be any kind of top-down control or organization where you have multiple groups asking similar questions that say the biobank or ABCD should have an awareness of exactly who's trying to get at which question and try and pool those resources somehow then?
No.
Yeah,
No.
I think you're entering really dangerous territory.
But to be clear, I mean, there are some repositories that work like that. I mean, we don't know them because they're hard to access. Some epidemiological data sets, you have to come in with a question. And then you have, if that question's already been asked by another consortium member, then you wouldn't be allowed to do that, or they'll tell you to go collaborate with them, which is not very practical. So those things, while they are well intended, always seem like, a mechanism to make sure that just the people who own the data get to do what they want with it. And I should add that in the early days of the UK Biobank, they were much more focused on, you had to give a very specific question, and then you would only get those variables. I mean, anyone who's gone ask for access, you have to justify why you're getting access to each of them. And I think there was pushback early on, like, well, how could you possibly need all of them? Yep. And we were able to make that case by saying, well, this is basically a data mining exercise.
And so to change topic a little bit, any points or questions on that? Okay. There will be a roundtable later on today as well, so it's a good opportunity to ask questions of the panel. So to change topic a little bit, so with these large data sets, to what extent do you think they're culture fair, and particularly to you, Suzanne, you've been considering these issues?
I mean, I I was one of the people who proposed this community topic, mainly because after the Xingwei Li 2022 Science Advances paper was presented at last year's OHBM, it's bothered me that they're not even culturally fair within the data set. So that, you know,
So
you're...
could you just reprise that result?
So they went through both HCP and ABCD and looked at sort of building predictive models, resting state to behavior, looking at white Americans and African Americans, because those were the two largest populations. And in every case, whether or not they use training on equal age match, all match sort of white American and African Americans, the model always performed better on the white Americans. If they trained the whole model on the African Americans, it still performed better on the white Americans. And generally speaking, they were finding that there were unhelpful and potentially discriminatory sort of biases that were coming out of the predictions. So that African American children in the ABCD data set were being found to have, you know, were predicted to have higher scores on behavioral questionnaire, like school behavior, so acting out and things like that. For the adults in the HCP, it was saying that, well, no, they don't experience as many life stresses. They have it over predicted their access to social services. So there were strong implications that even within these data, you know, even within a single data set, that it wasn't fair for the non-majority populations in the data set. And I feel with machine learning, it's very easy to suck all of that data in, produce a nice model, and then not go back and figure out what the biases might be.
I think, yeah, we need more data in more communities. And that ties into another panel session we had about international data governance and data sharing. And that's some people working on that, trying to make it easier to share data across borders.
Yeah, and it's not only just sharing data, right? It's collecting data in a variety of different places, in a variety of different countries and continents. And sometimes there just isn't the expertise to even start. Right.
Or resources, low resources.
Resources. And so it feels like if the community does feel like this would be a valuable resource to have a data set from a sort of non-standard country, then even if someone from a richer country is planning to set up a data set, why collect it in another one of these sort of European and North American countries? Why not collaborate with another institution somewhere else and access the Western funds to collect data from a non-Western country, and then have some sort of collaborative initiative, and you're bringing both the funds, expertise, your capacity building in a different place that doesn't necessarily have access. And I think these are the only real ways of solving these problems. I don't think it's going to be a statistical approach to solve these problems just because there's no data.
Well, I think also we need to think about the measurement techniques, because a lot of the questionnaires that are used are all validated from like the 1960s and 70s on white Americans. And so, or white, you know, majority European. So I think there's also sort of little bit of soul searching as well of whether or not is this the correct questionnaire for this non-Western country.
But I think if you embark on a large project in a country that is not Western, then these are things that you're going to have to grapple with, like on the ground, and it's easier to grapple with them when you have an actual project rather than grappling with them in theory.
Yeah. Was there a question here?
Please do. Yes.
Do you want me to speak in the microphone?
If you want to come up and talk in the microphone, that'd be great.
Are we streamed?
We are indeed, yes.
Okay.
And also,
She's gonna be slightly off screen.
for those that are joining online, please do put your questions in the chat.
Just going to the point about thinking about collecting data in, say, non-Western countries, I think you said. One of the issues is that there are many countries that don't even have a single MRI scanner in them, right? So it's a little bit more of a difficult problem than that, you know, some large sections of sub-Saharan Africa that just don't have an MRI scanner. And even in a country like Australia, which is very wealthy and has lots of MRIs, they're not in regional areas where, say, the Indigenous population live. So it's actually a little bit more of a wicked problem, right? That the technology just isn't there. And there was a presentation at the diversity symposium about these ultra low field portable MRI scanners, which look really, really promising. But then, of course, you have the issue that you're, acquiring data in some people at 0.06 of a Tesla versus like 3 and 7T in metropolitan rich areas. So I don't really have an answer other than just to say it's a harder problem than that.
It's super hard.
I've been in one of those. The image quality is pretty reasonable for structural.
It's surprisingly good. We have one. It's surprisingly good. But if you take the project that's being run at my institution, they're acquiring the data at 0.06T and then at 3T and trying to develop machine learning to improve the quality of those, which, as you said, is already kind of surprisingly good. But of course, if we're applying, deep learning and machine learning to improve these images, of course, you're still doing it on the brains of people who can get to a 3T scanner.
And also, I just think you'd say if you have to ask even a more fundamental question is if there's a place with so limited resources and then you can get an MRI there, is doing brain research the best use of that resource. There are probably actually way more important things in neurological, stroke, whatever other health things.
But there is possibly a middle ground, right? Just because you can't necessarily do it in some places that don't have an MRI scanner or who have overwhelmingly larger problems. There are some countries that perhaps do have MRI scanners that aren't very well represented and could sort of embark on this research, but just don't have the resources, don't have the expertise. And so we shouldn't let the fact that we just can't do it everywhere prevent us from expanding out to places that could.
Yeah, and I guess in China they're building these kind of larger data sets as well. Do we think that over the next 5 years there'll be equal representation of machine learning and various algorithms tested in these kind of Asian data sets as well? Or
well, but I think within the Chinese data set, they still run into the same problem that it's majority Han.
Yeah.
So they're also they're suffering from the same problem as, Human Connectome and ABCD and UK Biobank. So yes, it adds a non-Western perspective, but within China, it's still, suffering the same problem. So I think sometimes we have to shift from our Western perspective of thinking, oh, well, now we have, a Chinese data set. Well, that's not Western, but if you're a minority in China, that also isn't representing you.
Yeah. So did you have your hand? No. Okay. Any other points in that? Okay. So
there's one hand there.
Oh,
yeah,
sorry.
come on up, please.
Please come up. And also, if you want to say your name as well. Thank you.
Hi, I'm Lonnie. I was just thinking there's been a lot at both this meeting and last one about normative models. And so I was just thinking about that in the context of what you're talking about today, because they're often presented as kind of this, not idealized. I don't think people are overstating them too much, but we have these very specific weight and height charts, and we can plug an individual in, and they are kind of being presented sometimes as this tool that almost anyone can access. If you have metrics from your person, you can plug them in, but I'm sure that they're also subject to some of the same issues, even if you try to pool across lots of data sets. So I was just thinking about that for discussion.
No, it's a huge concern for normative models. Yeah, I think in some ways it's always a concern. It's just that I think normative models maybe seem to promise more.
Okay, so one thing that's come up as well with these very large data sets is the fact that you have many terabytes of data. When people are downloading them perhaps repeatedly within an institution, there's a large economic cost, there's a large carbon cost for this as well. How much of an issue do you think this is? How do you think people are starting to address some of these concerns about large data set use?
I was going to say at Western, we have a sort of internal computational server for neuroscience. So if you make a reasonable proposal as to why you want your large data set, we actually start sharing the costs and storing them centrally. So we do the download once. And then we also will help the groups with the research data management to figure out, okay, what set of this data do we want? Do we want to do some cleaning ahead of time? Do we want to also give the pre-processed data so we aren't wasting resources having every group rerun fMRI prep on, say, the Healthy Brain Network out of the Child Mind Institute? So I think there can be a lot done at the institution level of just having. I'm a support staff member, so I'm all for our role in sort of helping groups be able to sort of manage that and basically download and produce sort of the most general data set you can for your institution so that people aren't having to repeat a lot.
So I think this is a harder problem for like small institutions from small countries that don't have this support, because this is ideal, right? Where you do have a support staff, they're downloading once, there's support for managing this like insane amount of data. And if you're coming from a smaller place with not too much expertise, I mean, no one person can do everything or know everything. You may have to just settle for having a much smaller data set or something manageable, just because you just can't cope with the amount of data, either compute or even just storage or so I think even in this regard, maybe it can be maybe solved partially if there are like heavily pre-processed data sets that can be downloaded, which are much smaller, at least in size, and more manageable for smaller.
Yeah. Well, I think the cloud resources would be important. And if I were to channel Naomi Allen, who's the Chief Scientific Officer of the UK Biobank, she would say that no one should download the data anymore, and everyone should work on our cloud and on DNA at Nexus, and that avoids all this repeated downloading. But just to stress what an incredible resource that Steve Smith and Fidel Alfaro Almango have done by doing all this, once, and sharing it.
Yeah.
Did you have a?
But you can also say your name as well.
I'm Dustin. I work for the NIMH. I'm also on a support team that works on managing these large data sets for NIMH. And I think about these issues a lot. There's kind of like things that could change at the data set level, at the institutional level, and at the researcher level. So at the data set level, some of these large data sets like UK Biobank or ABCD has already been mentioned. The data use agreements are attached to specific projects, which kind of prevents the flexibility of having a large like institutional organization of the data set for everybody to access. It's totally possible because we do it, but just know that if the data set requires a specific project and your access, like for UK Biobank, the subject IDs are generated separately for each application. And so if there are multiple applications within institutions, then that's inefficient because you have to download, you have to organize them. But also at the institution level, there needs to be the resources to manage that. Like we are lucky that we have a very large cluster that we can access it. But if there's still a very modular approach to where each lab has their own server,
That's also, I guess you're saying you take on responsibility for access management, basically.
Yeah.
When you do that.
But then there's also responsibility at the group level, at the scientist level, because this has happened to me where I manage the UK Biobank for NIMH, and I've run fMRI prep on everybody, and then somebody comes to me and says, well, I want this version of fMRI prep or something. And so there's a tension between the resources required to do it and the complete freedom to have what you want. And so it's nice that like UK Biobank or HCP provides a lot of derivatives and people can use those, but scientists need to be like, well, I might not be able to get everything that I want. Let me try to work within this framework.
This flows perfectly into the next point.
And so yes, it's the next question then was about best strategies for quality control and to sorry. So it's thinking about the best strategies for quality control of large data set images. Like, what kind of problems should people be looking out for when they're looking at images, looking at IDPs, and so on?
Like, I guess the first thing I'd say, I would just jump into the missed opportunities I think there are for collaborating on that, right? There really should be. It is absolutely silly that there are, maybe a half dozen groups who've analyzed UK Biobank data at scale and we've rediscovered weird subjects, and why aren't we sharing that information? That's something that should be a priority.
I was going to say, I went to the quality control education session, and they talked a lot about sort of why you have to run quality control on these large open data sets, and you as an end user should not go in assuming that the data is perfect. But they were finding everything from, registration errors to people where the acquisition was completely upside down. So there were all sorts of fun and creative things that you can find in these large data sets. I was going to say, we do a mix at Western of sort of semi-automated. So we've run them through fMRI prep. Let's suck up the motion, the head motion parameters, and immediately set a cutoff and get rid of people that way. But unfortunately, with images, eventually you just have to look at them. You have to look to make sure that registration, went correctly, or that free surfer, found the boundaries of your brain. And if you're if you're in a really small lab and it's just you, that becomes a problem where I feel like there could be a community more driven approach of being able to go back to, say, Human Connectome Project and basically say, hey, we found these subject IDs where there is something clearly wrong with the data that's uploaded. Can you flag them so that future people aren't able to download them, sort of thing? And I think that would probably be helpful to go back.
I think HCP does have something like that, but I think it also depends on the place where the data is being collected and stored, and the I think we're coming to this, but the data protection regulations around this and what they can and cannot do. And I think we're restricted by that.
Yeah, I mean, the UK Biobank gives everyone unique random IDs, but it is true that any derived information that you extract from UK Biobank should be returned, which is actually kind of funny because it makes it sound like actually strictly you should return all of your fMRI prep results to the UK Biobank. They do not want them, I guarantee you. But extracted summaries, like bad subjects, something that could be returned, and then other people could get access to that.
And so you touched on the kind of like the legal implications of creating these kind of large data sets. What implications are there for that? How can researchers navigate, the different issues brought up by different regions?
So I'll start with this one because I spent a lot of time thinking about this, and I think the first thing we need to do is, and I think that the onus over here is on researchers, primarily I think in North America, to not assume that the rest of the world operates in the same legal framework as they do, because really don't. Europe has a very, very different approach to legislation on medical data in general, and the rest of the world does too, and sometimes, very often, I think, conflicting, and there may not be a way to perfectly harmonize all of this. And when we come to talking about best practices, it's usually again led by primarily North American and some European countries setting out the best practices, and sometimes these best practices are in direct conflict with what you are allowed to do by law. And so
at the hackathon, there was someone from Europe, Camille Momet, stood up and said, GDPR is pretty clear that brain data is identifiable information and cannot be shared openly. So basically, open neuro is illegal. I mean, it hasn't been blocked yet, but I mean, it is not compliant. It violates GDPR.
Well, I was going to say, so I'm originally from the US, but now I work in Canada. And even though, Canada has a very US approach to, as long as you consent and, it's all written out in the research participant has okayed their data sharing, there are implications. So for Indigenous and Aboriginal populations in Canada, there is a completely different legal framework and they own their data. So if you research in Canada on Indigenous populations, the Indigenous population owns that research data. And so even within a same country, there can be very different rules and legal implications for how.
That's much more similar to a European approach, right? So as a European researcher, if you have a data set, you're not the owner of the data set, you're the controller of that data set. And the research subject, the data subject, has all the rights, or maybe not all the rights. There are some derogations that are possible. But it's really important to sort of understand these things. And I think we need to, as a community, engage more with the diversity of laws across the different continents. And also, maybe it's time for OHBM, and I've seen this starting to happen, but for some sort of interested tech lawyers who are interested in this sort of space, to come to OHBM and to engage with researchers, because my experience is that most neuroimagers really don't want to deal with this. Most lawyers don't have a clue, and we're just it's just we end up with really conservative readings of the law, and people not agreeing or sort of doing things that they probably shouldn't do, and hoping that nothing happens.
Franco Pastilli was on a panel the other day, so he's created a project with the support of Welcome to create an international data governance framework, and that he has money to hire lawyers to get consulting. So it's a daunting task, but that's one person who's trying to go forward, and he's got a letter of support from the OHBM, to say this is something that could be, brought to that level, to the OHBM level.
Yeah, I think this sort of thing is, imperative.
And so, please come up.
We have a lawyer in the house. We have a lawyer in the house.
Hi, I'm Jamari, and I'm from the Netherlands. And I also dove a bit into the legal stuff when it comes to not so much the brain data, but instead the stimulus that we are using. Because what I've found is that in general, for English-speaking countries, I don't know it's for everyone, but in general, if you're using like something like a movie for the sake of science, then you're good. In the Netherlands, however, I encounter so many issues with, if you buy a DVD and then a friend of yours borrows it, that's actually illegal. But I believe that in the time that DVDs were like actually a thing, then we completely ignored it. However, when I'm now working on my own experiment and I want to use like a Dutch movie or a Dutch audiobook, which I may or may not be using for legal reasons, I won't be vague. But what I find difficult is to say that in my paper I have used this stimulus, because I'm afraid that the actual holder of that stimulus will come to me and say, yo, you have presented our movie to 60 participants. You are not allowed to do that, so you have this big fine.
So there's not a science carve out.
No, indeed, there's no exception for science. Sorry. So that also means that it currently it does seem like most movies will be movies from America or on the English-speaking countries, because I may or may not be able to make it actually open. So I wonder, do you know anything about possibly like what the science community could do to try and make a difference in this? Possibly.
Generate license-free content.
Yeah.
Let's make a movie studio.
OHBM movies. I don't know. I think it, unfortunately, again, depends on the individual countries and the way they legislate, and also to a certain extent, the companies that are making these movies, that they are able to potentially give permissive or some form of license for research purposes.
I think Michael Hanke got that for the German audio of Forrest Gump. I mean, it wasn't easy, but he got permission to share that.
One way to do it obviously before you start your project would be to contact the copyright owner and start from there. See if they're okay with it.
I was going to say, sort of small steps would be, I want to show this specific, say 5-minute clip out of your 90-minute video or 90-minute movie. So then it seems a little bit less like you're reusing the entire movie and showing it for free to people, but you're extracting something that maybe is in a trailer that's already on YouTube or something like that.
Yeah, I want to quickly comment on that because we did consider, let's contact the big, huge, rich company and ask them. The issue was, however, if they said no, we could not use it. If they said yes, they may be saying yes, but you have to pay us this much, which we probably would not be able to do. And therefore, we did not really want to ask, because if we were to ask, they would know.
Yes.
And now I still finally kind of have the assumption that they probably will not check neuroscience papers.
Yeah.
So I have that hope. So it is a risk. I do understand the possibility, but again, it depends indeed.
I would definitely start
country.
smaller. If I don't know if any smaller studios or smaller production houses, that might be a better place to start.
But I think even in the US, we struggle. Like, you can show the movie for, clips of it for research purposes, but we can never upload that stimuli to someplace where other people can download it. So there are limits even on our ability to. So if you have a paradigm with movie or TV shows, we can't make that paradigm openly available to people. So,
I mean, the other thing you could do is, this is a long-term solution, but lobby to your, to your government or science organization, or depending on the structure of the country, and they could come up with legislation that kind of protects scientists for these use cases. And very often, perhaps legislators will be more open to this sort of thing, and it's just maybe not there because they never thought of it, right? So,
Do you want to come up?
My name is Jeroen Rieger. I'm from Oldenburg University. The way we tackled this so far, and I think this is a real obstacle for open science, in particular, if you want to do open science with complex, realistic stimuli. So the way we did it so far was that we, first of all, in the selection of our stimuli, tried to select stimuli which were open, or not copyright protected. Second, we actually contacted whoever held the copyright and asked them, and 80% of them were open and gave us basically released their copyright. And from the others, and this is the other important thing, I think, strategy that I think was not mentioned yet, is if it's a closed source, add an RRID or a whatever idea that that identifies the source that you had, and even if it's a commercial source, so that the next researcher can find exactly the same stimulus source.
Nice, good idea.
So kind of a related question. So it feels like, yes, once you open Pandora's box, you realize all the problems that are within. And so next question is really, what are institutions or consortiums doing to support large data set use? And I guess flagging these issues in places like OHBM is one way to put it on the agenda. How do you think they're taking the lead with these issues?
I don't know. I'm just thinking about the fact that my institution has just gotten, now if I want to download any human subject data set, even like from Open Neuro, completely free, I need to like now fill out this form that certifies that it's ethically sourced and it can be considered as anonymous, which probably it isn't with respect to GDPR, but it's certainly in my institution, it's getting harder. But yeah, I'm not sure what else.
Yeah, I was going to say, I think removing some of that red tape instead of adding additional hurdles would help. But I realize every institution, every country, everyone's all got their different rules of, and it's hard to harmonize across.
I think in Europe, one thing I would maybe advise is sort of if you try to engage with your data protection officer, like if they at least attempt to understand what you're trying to do, it might be easier. They might sort of try to engage with ways to facilitate things. I remember I had an experience with two data protection officers from my institution. One of them was incredibly conservative. She basically didn't want anything to happen just because it reduces liability, and the other one was incredibly open and available to sort of discuss things. She'll obviously say no if you're coming up with something completely crazy, but start engaging with the people who are involved in this, and if there aren't policies and procedures in place, and maybe you will have to set them up.
Fairly daunting then.
Yeah, it is.
Yeah, but I mean, sometimes that's the only thing. I mean, that's the only way to do it. If you're doing something that's completely new at your institution, you cannot really expect that someone else will do it because you're the one who's interested in doing it. So you kind of have to do it.
But I mean, I'm at, a well-resourced university, and generally the data governance people the information governance people are completely under-resourced and overwhelmed. And what's this thing called a DPIA? Which is
a data protection impact assessment. That's fun.
Which is done. And we have a project, that has been going on for 5 years, and they've had it for 3 years, and they like about every 9 months, they come back with like a little question, and we answer it, and it goes back to them. It's never been approved. So our department approved it, but it's never been approved at the institution level as it should be.
Oh, wow, yeah. Yeah, this is the thing. I think in Europe, it's becoming like a never-ending pool of documents. So these data protection impact assessments are like 25 to 50-page documents on how you're respecting data subjects' rights. I had a sort of a recent story about one of these. We filled one out for a project we're trying to do, and we presented it to the Data Protection Authority. And their response was, well, can you also now write a risk assessment? So we had another 15 to 20 page document. So it's just never ending. And it can be really onerous, and the compliance burden can be pretty big if you don't have the support. So, yeah.
Yeah, but and what kind of benefits might there be for data protection as well? Because I guess there's so many negatives about going around it. But
I think with these documents like the DPIA and risk assessment, that there are benefits to doing them, right? Because you are forced to think about sort of how you're going to be processing your data in minute detail and what the structures are and who is going to deal with every single issue, and that there are a lot of benefits. It's just if there isn't the sort of background support, it just feels incredibly
well,
daunting.
and also it is the right thing to do in terms of you wouldn't, there could be a freely available data set out there on Chinese prisoners that would have data collected without consent.
Yeah.
And do you want to download and store them and use that? And that's maybe not something you want to do. And so it makes sense to verify the ethical provenance of the data.
Hey, I'm Ghislain from the Paris Brain Institute. I was at the Brain Hack, actually. I wasn't the person commenting on Open Europe, but actually I share the same assessment that based on the GDPR, because the data aren't, not all the data are defaced, technically you could identify the brains, and as a result, you, like, from the perspective of the GDPR, you fall against.
I think Kemi's point was that even with the defaced, because of brain fingerprinting.
Indeed. Here we are talking about the fact that we need to do all these risk assessment and stuff, but it's often because we forget that within the GDPR, there's also the fact that if bad things happen, you're liable, like you're responsible for the security of the data. That's often the point that is misunderstood, is that you can do everything you can to, like, anonymize and put any sensitive information away. And not every policy can be perfect. And if it wasn't perfect and leaked data falls within the bad actors, you're the people responsible for them. You or your institution, or in our case, it would be the head of the institute. But that's why I think as a researcher, I got more respect to the DPOs and all these people who do all the regulatory things, because it might have happened that we got hands on, when you talk about Open Euro or UK Biobank or these, the data curation and anonymization, everything has been done by a third party, so you kind of trust them. But when you deal with hospital data sets that are local to your trusts, has happened a few times where you look at the data that you were handed over and you realize, hang on a minute, this field is not supposed to be there and this is sensitive, and how do you deal with it? Do you do it quietly under the carpet, or do you it's always these things?
Yeah. So just very quick. I mean, with you are right that the institution is ultimately responsible if things go wrong. And it does matter if you've done all these things, right? So if you've done a data protection impact assessment, you've done the risk assessment, you've done everything you can, but there still has been a data breach. The Data Protection Authority will take sort of the measures into account and the mitigation approaches. You probably will still get fined, but there also are differences in fines for, as far as I know, I'm not going to be 100% sure about this, but if you're a public institution or a private company, the fines are less for a public institution than the maximum fines for a private company. So there is that. But yeah,
I don't think you want to be having that conversation with your.
No, you definitely.
Don't worry, it's
you
not going to be
definitely-
millions, just a couple 100,000.
Yeah, you definitely don't want to be doing that. But
Want to come up?
Yeah.
We have a
Yeah, do you
question.
want to come on?
Is there a question online?
Yeah,
It's actually way more.
we'll come back to the question online afterwards if it's with that.
No, but I mean like HIPAA.
At that point, remark that there are also so-called contractual solutions, and that is data usage agreements, which basically exclude, for example, de-identification from as a use. So there are sometimes, for seemingly complex problems, relatively simple legal solutions. And they are not, it's not that we cannot implement them. So please do not say that the GPDR is basically ruining our research and data sharing.
Yeah, well, and a great example of that is the Human Connectome project, which has a data use agreement that you sign and you agree not to de-identify it, but you get to click through that, and that's amazing.
That's it. No, data use agreements are super important.
Yeah, so we have a question online as well from Inez Almeida. So they're asking, what are the recommendations currently if you're uploading a data set with identified issues during data acquisition, but still possible to correct? So start at that point. So this goes back to quality control a little bit.
Well, the zero thing, of course, is that you must have your ethics lined up, right? So that the subjects have consented for onward sharing. That's the zero thing.
But I think the question was about uploading things that have some
Errors that could
errors,
Yeah.
QC errors, or
Yeah.
so some data processing errors.
I mean, I do know that the people who were involved in the initial data sharing with resting state data, like FCON 1000, and Cameron Craddock in particular, I remember, was saying they debated. Some of the data was just crap. Like, they knew it was really bad, but they decided that they didn't want to be the people deciding which was too bad, because sure, there may be easy cases, but there's a whole spectrum, and they just thought it was better to share everything and then perhaps annotate it. And
So this is
I
what-
would say annotation, so that someone, if you're an individual researcher at a small facility or small lab, you don't have a lot of know-how, knowing what issues and what steps you may have to go through to fix poor data, then you can make the decision of, well, we don't really have the expertise or the manpower to do that. So now I know I can immediately exclude, this subset of data that are usable if you have enough know-how and enough manpower and time to do it. But
and I suppose maybe it also comes down to, is it like a small subset of the data within a larger data set that's poor, or is it the entire data set that's like has some systematic problems? I mean, is it then worth uploading that if you know that there are some serious problems in the entire data set? So I think there needs to be a kind of a call, a personal call to see, is this worth sharing?
And so, yeah, one thing they ask is, should they then publish lightly processed raw data where they're trying to account for some small issues in data acquisition?
I think if it's documented and what you use to lightly process your data is openly available so other people can actually go through and see what the steps you ran were, I think that would be a fair assessment. I think it would, and I think going to your point, we're discussing issues of scale here. If it's your single study that's going up on Open Neuro and you had, 40 to 50 participants, I think that's a different issue than if it's something like UK Biobank and they discovered that you have a systematic problem across, thousands of data sets. So I think weighing those, but absolutely making sure that you document everything and sort of make everything as open as possible so that everyone knows what you did.
Yeah.
Thanks. And I introduced myself before, but I'm Shana from Monash University in Australia. So I just wanted to return back to one of the earlier questions that Suzanne posed about the fact that, we're using these large data sets and they are hugely valuable. And I'm also a fan of not letting perfection get in the way of progress, right? Like they're valuable and we should be getting value out of them. However, so when we are using them to do like machine learning and classification and normative modeling and things like that, how should we be dealing with the fact that they're not perfect data sets? So just for a reference, I've just recently become a handling editor for one of the neuroimaging journals. And, I'm kind of getting inundated with like all these kind of classifier papers and machine learning and so forth. Is it just simply, acknowledging that, there are biases in the data? Does anybody have any ideas about, practically how do we deal with this now?
I mean,
I've just been asking
there's
people.
always, as you say, it's never going to be perfect. I mean, everyone's just doing the best they can. But I think just demonstrating that you have done the best you can is.
Yeah, I've just been asking people to put a line in saying, acknowledging, the limitations of the data set that they have. But I don't know if
that's part of any good scientific paper.
Yeah.
I think maybe also as more, I think what you guys brought up early of using a test set, maybe that is completely unrelated to the training set and sort of forcing people to not just use a subset of, say, UK Biobank to validate a model that was built on UK Biobank data, but to sort of go completely out of sample and sort of do it that way. But I mean, the problem is it's still bulk, American, Western European data out there. So you are validating a model that was, tested or trained on Western European American data and are largely testing it on that. And so, yes, you can generalize outside of, say, UK Biobank, but you can't necessarily generalize to a completely different population where we don't necessarily have large scopes of data. So it is a little bit that it's the creators of the data sets that are largely benefiting from all of this sort of machine learning and, models and stuff, rather than potentially smaller labs and sort of populations that don't have access to.
Yeah, I mean, I don't necessarily think that smaller labs or smaller places don't get any benefit, but their benefit won't be the same.
Yes.
So, I mean, I'm just thinking about back home. I come from a very small place, and we have we have a history of, we were a British colony, and going back to normative curves, I mean, when babies are born, they're plotted on normative curves, and we use UK normative data, and we're a much smaller population. I'm a tiny person, and yeah, it's not ideal. It's not useless to
Well,
us.
I'm sure doctors from Malta know about this, and they
Yeah,
That's right.
they
It's
compensate.
internally
They
correct.
compensate for it, and they know what these. So we are benefiting from these sort of normative
Yeah.
curves, but they're not ideal. So I wouldn't say there's no benefit
Yeah.
to other countries from these large data sets that are not specific for sort of wherever, but it's not ideal.
Do you, Damien?
So last question. Yeah, no, on you come.
Just on that discussion, especially for what a handling editor could do, I totally agree about acknowledging in the publication, acknowledging the bias, but also being very clear about inclusion and exclusion criteria. Ideally, that this isn't possible with many of these large data sets, but you would have a subject list of everybody that went into the different groups so that the reader or the researcher who's coming to your study can, acknowledge the bias themselves or explore the biases themselves, but at a minimum, having very clear inclusion and exclusion criteria so that people can, assess that.
Thanks very much. So I'd like to thank everybody for attending today, and a huge thank you to the speakers as well for grappling with some of these issues. So thank you very much. If you do have further questions as well, there'll be a round table.
I was going to say
15 minutes, so
later.
it's not far off.
15 minutes is later.
Oh, I gotta eat something.
I
My
need to go
stomach
get
stops.
coffee.